Hi, everybody. Okay, we are going to do number 72 in the book on page 440. Okay. Before I ever start a problem, I like to list my before and after. My befores are my ones, and my afters are my twos. And in between, something has changed. We know we're always going to be using the combined gas law. That's the only law I'm having you use. And so we know we're using pressure, volume, and temperature. So I just set it up, and then I read the question. What I'm looking for is the set of conditions before the change as my ones, and then the new set of conditions after the change. So the question reads, a 3.5 liter gas sample at 20 degrees Celsius and a pressure of 86.7 kilopascals expands. So those were the befores, or the ones. So a 3.5 liter gas sample is my V1 at 20 degrees Celsius, that's my T1, and a pressure of 86.7 kilopascals is my P1. Okay, I keep reading. It expands to a volume of 8 liters. That's my V2. The final pressure is 56.7 kilopascals. What is the final temperature in degrees Celsius? Okay, it's asking for us for temperature in Celsius, but you can't use Celsius in the gas laws. It doesn't work. Only Kelvin will work. So over here on our T1, in order to convert our Celsius to Kelvin, we add 273. So we're going to be using 293 Kelvin. Okay. For volume and pressure, you can use any unit as long as the ones and twos are the same unit. So we can have liters and liters. We could have milliliters and milliliters. Pressure could be kilopascals or atmospheres or millimeters of mercury, as long as they're the same unit for the twos. Once we have this set up and we know what we're solving for, we just write down our combined gas law and circle what it is we're going to solve for. That just helps us keep track of it. Now, let me just stop for a moment here. In this question, everything is changing, but in some cases, not everything will be changing. So let's say temperature is not changing, only pressure and volume. If temperature is constant, we just take it out of the equation. And now our equation is P1V1 equals P2V2. If pressure is constant, we just take pressure out of the equation. And we have V1 over T1 equals V2 over T2. Okay, but in this case, all of them are changing. And now we have to solve for T2. Okay, you cannot solve for something if it's on the bottom by leaving it on the bottom. You have to get it to the top first. And so we want to multiply both sides by T2. So if I put a T2 here, that will get rid of that T2, and that disappears. And then I put a T2 here, and it stays there, and that's where we're going to solve for it. So right now, just imagine there's a T2 up here. And I've written it down here. So we know this is what we're solving for, so I'm going to put T2 equals. I'm keeping my finger there because that's where my T2 is, just to keep track. But now these three things are still on the same side. In order to solve for it, I need to get rid of those by moving them to the other side of the equal sign. So I can either multiply both sides by something or divide. But really what you're doing physically is just moving them diagonally across the equal sign. Like I moved the T2 from here diagonally up here. I can't move it straight across, and I can't move it up to the top here. It has to be diagonally across the equal sign. That's the exact same thing as multiplying both sides by something or dividing both sides by something. So we're going to take our P1, V1 and move them down below, like so. Notice I'm leaving this here. Our T2 is here. Our P2, V2 is already on the other side of the equation. So I just put it on the other side of the equation. My P1, V1 go down here. They end up here. In my T1, I move diagonally across the equal sign next to my P2 and V2. And now we have our setup. Now, a common mistake is to mix up the 1s and the 2s. Because it depends how it reads in the question. Sometimes we just read and put it in that order. But that's why we set it up like this. The 1s on this side, the 2s on that side, so we can be very careful about this. So our P2 is 56.7 kilopascals. We just put it in there in the exact same order. Our V2 is 8 liters. Notice I didn't put the 0.00. That's just because I ran out of space and we're not worrying about significant figures. Okay, our T1 is over on this side. It's the 1s, 293K. We have to use the Kelvin. P1, 86.7. And V1, 33.5 liters. Okay, now in a different problem that I assigned earlier, you ended up with the same actual equation here, and I noticed that some people had them switched upside down, the P1 and V1 on top and these 3 on the bottom. That was because they solved for T2 where it was. That's actually solving for 1 over T2. So you have to get it to the top first. Okay, now we have this all filled in. We just do our math. 56.7 times 8 times 293, hit the equal sign, divided by 86.7, hit the equal sign, divided by 3.5, hit the equal sign, and we end up with 437.9 Kelvin. Now, notice, because we have everything on one side of the equation, we can see the units cancel. Our kilopascals cancel, our liters cancel, and we're left with Kelvin. But a lot of people were just filling in the equation like this. And you can't see units canceling that way. It's okay to do that in math, but in science you have to show unit cancellation, and so that's why we're doing it this way. Okay, but it asks us to solve in Celsius, and we solved in Kelvin. So now we have to subtract 273 to get to our degrees Celsius. Okay, when it comes to the time of the test, this answer is worth 2 points. 1 for the number, 1 for the unit. But that's not the only skill I'm asking you to learn here. So getting the answer is only 2 of 6 points. Okay. This is another 2 points, is everybody will start with this. It's just assume that. But ending up with a rearranged equation with the variable that you're solving for on one side and all the other variables in symbols on the other side, that is worth 2 points. And then filling it in with your numbers and your units so that all shows cancellation, that is another 2 points. So every math problem will be worth 6 points. 2, 2, and 2. Cross multiplication, if you do it that way and you get the right answer, you'll end up with 2 out of 6 points. Okay, I hope that helped everybody. Bye, I miss you guys.